Hi everyone, it's a Thursday, we're talking tech, so it must be a Derivco Tech Thursday webinar. I'm Lee Naidu and I'll be your host for today. This is our second one in the series, and this time around we'll be learning about SQL Server 2019 Big Data Cluster, presented by no stranger to these sessions, Niels Berglund, software architect here at Derivco. To keep you in the loop on how the session will flow, let's have a look at today's agenda. First up, to officially open the event, we have our CEO, Kiresh Bihari. Niels will then deliver his talk, which is titled A Lap Around SQL Server 2019 Big Data Cluster, which should run for about an hour, followed by a Q&A session. We then hand over to Rob Thompson, Executive Group Head of Player Experience here at Derivco, to say a few final words, and then it's back to me to wrap things up. Just a few things to note. I'm sure all of you guys are pretty well versed in this for now, but questions can't be asked verbally, so simply just drop them into the question bar. Just look for the question mark and speech bubble icon to the top right of your screen. And finally, there's about a 15 to 30 second delay, so just keep that in mind. I think that covers everything. We hope you enjoyed today's session, and feel free to share, tweet, and comment on social using the hashtag Derivco Tech Thursday. We are active on Facebook, Instagram, as well as LinkedIn. In one of our last webinars, I tried to deliver a cheesy joke and it didn't land. And I kind of found out exactly that it didn't land because you guys actually told me this. But I do know someone who actually successfully brings on the cheese from time to time. He may actually bless us with a perler today if we're lucky. It's our Commander-in-Chief, our CEO, Kiresh Bihari. He's up next to officially open the event, so let's give him a virtual round of applause. Over to you, Q.
Thanks, Lee. Appreciate that intro. It's the worst one yet, but we'll try. Welcome to everybody else that's joined us this afternoon. Afternoon in South Africa, hopefully for people joining us around the world, none of you from the States getting up in the middle of the night, but I think that the audience that we're talking to today, most of you have joined us because you're all pretty much experts in the field that we're going to be discussing. So hopefully you'll find today interesting. From a Derivco point of view, we chase the cutting edge of tech whenever we can. And we've been following this journey for a number of years while big data became the keyword or the buzzword that was used in every business. All of you know that data's become the major topic of governments around the world, different entities, corporates, governments, the whole lot. And pretty much to survive in today's corporate environment, you have to have a data-centric business. You've got to make sure that all your decisions are based in logic, that your company is able to maneuver fairly rapidly. And then going down to the personal front, hopefully all of you are steeped in this type of experience. If you want to get better at anything, you require information. That information is data, and our ability to be able to work with it in a flexible manner is probably critical for any part of our businesses nowadays. We've tried that at Derivco for a number of years with different technologies, and having Niels Berglund, who I'll introduce shortly, be at the helm of kind of driving our strategy on new tech around big data has certainly helped our journey. We haven't kind of cracked it just yet, but we're making a lot of headway towards actually getting towards that destination that we were hoping to achieve. In the meantime, however, we're playing around with some new tech, and SQL Server has been our base technology for a really long time. Niels being one of the experts in our environment. His core skill, however, is being brutally honest. I once had him tell me that I gave an absolutely horrible speech at an event that I was at. He used a couple of swear words, so I'm not going to be able to repeat it here, but certainly helped me along on my journey. So today's going to be an interesting one. He's going to be brutally honest with you guys about challenges, the actual platform itself, the pros and cons of utilizing it, and then his experience of how you could actually harness it to improve what you do, whether it's for your working environment or in your personal life. So over to Niels, enough from me, and let's hear from the expert. Niels, over to you. And I'm going to be watching you this time, Niels, and if you do a really crap job, I'm going to make sure that I'll point it out to you.
Thank you, Q. Thank you for that introduction. How's it, everyone? I'm Niels Berglund. As Lee said, I'm a software architect at Derivco. I hope that everyone can see my screen. That must be the most used word ever in 2020. Can you see my screen? And Am I muted? Right. Anyway, so we're here to talk about SQL Server 2019 Big Data Cluster. And before we go into there, let me talk a little bit about something that is very near and dear to my heart, and that is data. So I've been working in the SQL Server database fields for longer than I care to remember, and data has been and is my passion. And if you're thinking about data, I have some quotes around data here, and we're saying that if you think about data, the civilization has always run on data. Right? So we had Moses and his tablets laying down the law. We had the cavemans with etchings, or you want to come home to my cave and see my etchings, as they said back in the day. That was data. We had the Egyptians with their hieroglyphs, etc., etc. Everything is based upon data. And so today, every aspect, I mean, data is around us, whether we like it or not. Maybe sometimes too much, but we are engrossed in data. And data, as opposed to other resources, data is renewable. I mean, think about it, we are running out of oil, things like that, but data just keeps on growing, growing, and growing. And even when we are slowing down, now in the COVID scenario here, 2020, trade might have slowed down, but data keeps on going, keeps on growing. And all these quotes is from a book by Brad Smith. Brad Smith is the lead counselor for Microsoft. The book is called Tools and Weapons, The Promise and the Peril of the Digital Age. It's an awesome book, and it lays out a lot what Microsoft has done when they went to the cloud, about the data centers, around security, around data, etc., etc. So if you're interested in this, I strongly recommend that you have a look at the book. All right. So the data landscape then. Well, we're generating more and more data, and there is an estimation that in 2016 we had around 16 zettabyte worth of data. Zettabyte is a lot. 1 zettabyte is 1 billion terabytes. So we had, in 2016, 16 of these zettabytes. It is, however, estimated that in 9 years' time, this will have grown tenfold, up to 163 zettabytes. And why do I bring this up? Well, I bring it up because of this data, and because we need to handle that. The problem here is, right, that the data is stored all over the place. And if we can't handle this data, well, we will be dead in the water. I mean, think about the dinosaurs back in the day, right? They didn't handle the data. They didn't analyze the data. They didn't see that the ice age was coming. So the ice age came and they became extinct. And we in the corporates, in the business, we can't allow that to happen. We need to handle the data. We need to be able to interact with the data. We need to be able to analyze the data, so we are not going the same way as the dinosaurs. So how do we then manage all this data? So Microsoft, obviously, since this is a talk about SQL Server, Microsoft obviously is SQL Server to be a sort of in the middle of this, and to an extent I can agree. I mean, if we are seeing the evolution of SQL Server, so back in the day, I'm old enough to have been running SQL Server 4.2, which basically was the same product as Ashton Tate / Sybase. And the reason why it was 4.2 was that was the most recent version of Sybase. And back in the day, back in those days, SQL wasn't really good, if we are completely honest. And it wasn't up until SQL 6.5, SQL 7, that SQL became a proper relational database. And since then, if we're looking at what has happened, so back then SQL 6.5 was essentially just a relational database. However, then it has evolved, so we introduced integration services, so we can do ETL and ELT and stuff like that. We introduced analysis services, so we can do analyze, so we can analyze our data. In SQL 2005, Microsoft, that was a huge release, right? In SQL 2005 introduced SQL CLR. And you guys that are from Derivco, well, you know how I love CLR, and you guys that are not from Derivco, ask any Derivkians and they can tell you awesome stories / horror stories, dependent upon where you're coming from, how I am using and abusing SQL CLR. We got XML support. We got a new data type called XML. We got later releases, we got JSON. And now we also have SQL Server on Linux and SQL Server in containers. So Microsoft sees SQL Server as the tool to manage all our data. And I'll come back to how they see that in a bit, and also how we can integrate data. So in Derivco, most of our data sits in SQL servers, but other corporations, other businesses, that may not be the case. So we may have relational data all over the place, even in, well, horror in Oracle, right? But we have to integrate the data. And then finally, once again, so not to become a dinosaur and become extinct, we need to be able to analyze the data and draw business value from our data. Because once again, if we don't do that, we're dead. Maybe not immediately, but quite soon. Cool. So, and that's where now SQL Server 2019 Big Data Cluster comes in. So SQL Server 2019 Big Data Cluster is out of the box, gives us Apache Spark and Hadoop file system. So when you are installing, when you are deploying a SQL Server Big Data Cluster, by default, you will get Apache Spark and Hadoop. Think about that a second. So Spark and Hadoop, that's open source. Back in the day, Microsoft was so against open source, so it's not even funny. I remember Steve Ballmer standing up at the conference and saying that, well, if it was Linux or if it was open source, was a cancer. Now Microsoft is embracing open source. Who'd think? By doing this, by having Apache Spark, by having Hadoop, by having other tools, we are looking at the ability to extend SQL Server to support data up to the petabyte range. We are not in the zettabyte range yet, but at least up to the petabyte range. And once again, we have Hadoop, HDFS in there. We want to be able to store any kind of data. We are not bound to relational data anymore. We want to be able to store any kind of data. And all this is based upon SQL Server running on Linux, in containers, in Kubernetes. So your big data cluster, your SQL Server big data cluster, is a completely different beast than your, inverted commas, your normal SQL Server. So your normal SQL Server still exists. You can run it on Windows, you can run it on Linux, you can run it in containers, whereas SQL 2019 Big Data Cluster, you have to run it Linux containers on Kubernetes. So the architecture. So having laid the foundation for this, having looked at it, kind of an overview of why we are going this way when we are going, let's have a look at the architecture. And here is now what I call the scary picture. And guys, you better take note. There will be some questions about this at the end. We'll have a little quiz. But anyway, so this is what a big data SQL Server big 2019 big data cluster looks like. And if we're looking here, we'll look at this more in detail in a bit. But if we're looking here, this SQL Server master instance. Right, that's your normal SQL Server instance that you are, when you are deploying an instance. Maybe it's the default, or maybe it's a named instance, but that is your SQL Server. If we're looking at what this here in the big data cluster, it is fairly small piece of the big data cluster architecture. And we have quite a few other SQL servers here. Right. So we're having here in the where it says compute pool here. Right. The compute pool, which we'll talk about in a bit, has lots of SQL Server instances installed. Just because we want to, we want to be able to do heavy load compute. We're having the data pool down here, also with SQL instances. We have the storage pool, which do not have SQL servers, but it has Hadoop and Spark, and actually a couple of SQL servers as well, for that matter. Even though we see that this master instance is sort of a very, very small piece of the big picture, it is important, because the master instance, that's the entry point into all this, right? And the protocol we're talking about here, when we're talking now down to the master instance, it's your normal T-SQL that we know and love. So even if we are executing queries down against HDFS here, right? We are still talking T-SQL, and we are getting to that data through the master instance. On the left-hand side, we have the control, what's called the control plane, where we're having a lot of, the control plane is essentially the part that communicates between Kubernetes, the Kubernetes framework, whatever we want to call it, and the big data cluster. And if we see here, part of the control plane is Kibana and Grafana, and Elasticsearch and InfluxDB. So in addition to having Apache Spark and having HDFS, we also get things like Kibana, Grafana, Elastic, and Influx. And then essentially, finally, all this now runs on Kubernetes hardware down here at the bottom, right? Cool. So that's the architecture. So how do we now? So yes, Niels, this looks awesome. How do I deploy it? I want to deploy it immediately, right? But as I say here on this in this slide, we're not in Kansas anymore. I mean, when I normally deploy a SQL Server instance, I take an ISO file, I mount it, and I run setup, and then a couple of minutes later, it's all done and dusted. Now, in the big data cluster, we are not only deploying that one SQL instance, we're deploying multiple SQL instances, and we're deploying Spark, and we're deploying Hadoop, and all that other good stuff. So when we're doing a deployment, we are running, we can do it in two ways, sorry. We can either run Python scripts, which Microsoft supplies us with, where we can target different environments. So we can target like Azure, or we can target a normal kube admin, or we can target OpenShift. So that's one way to do it. Or we can use Azure Data Studio and deploy notebooks in Azure Data Studio. And that's the lazy man's way to do it. So that's why I am doing it. But at the end of the day, when we are using the Azure Studio deploy notebooks, they will still be calling down into Python scripts. And then when we are deploying, we can choose whether we want to deploy it to an existing Kubernetes cluster, if you want to create a new Kubernetes cluster, how much memory, how much hard disk space, how many nodes, etc., etc. So instead of just talking about it, let's go and have a look here. So this is what I have up here on the screen now is Azure Data Studio. If you not have heard about it before, it's a new cross-platform tool for data. And well, it has Azure in the name, but I mean, everything in Microsoft nowadays has Azure in the name. So that's not really, you don't really need to be in Azure to use Azure Data Studio. I use Azure Data Studio a lot now when I'm doing normal things in Derivco. But anyway, so if you're seeing up here in the left-hand corner, you see connection, and you're seeing in those 3 dots the ellipse there, right? If I click on the ellipse, you can see here. Let's see if that works. How cool was that? We can see new deployment, right? So if I click new deployment, I now see that I have 3 options to deploy. I can deploy SQL on Windows. I can deploy SQL as a container image on Linux, or the final bit here, I can deploy a big data cluster. So I have chosen here SQL Server Big Data Cluster. I'm accepting all the terms and conditions. I'm signing my life away. And then I'm choosing here what version. At the moment, the only thing I can deploy is SQL Server 2019. And here, what do I want to deploy it to? And we are seeing now, I thought we were seeing now. Let's see again if we can see it. Yeah. So new Azure Kubernetes service cluster, existing Kubernetes cluster. Why I go into this are these 2 last rows here, last 2 entries. An existing Azure Red Hat OpenShift cluster or an existing OpenShift cluster. And why that is a big deal is that quite a few organizations, businesses are running Red Hat OpenShift. And up until quite recently, you couldn't deploy a big data cluster to OpenShift. But now in the, I think it's CU6 or whatever, that is now available, which will be a great thing for the uptake of big data cluster. Cool. Then we're clicking select here. We are loading some profiles that tells us what we want to deploy, how much, how many nodes, etc. And essentially, this is what it looks like. So this is all UI driven, and you are clicking through here. I won't go through anymore there, because this to deploy a BDC. When I deploy it from home here up to Azure, it takes around an hour to get it up and running. And we may think that is a long time. However, think about what is being deployed. It's a lot of stuff that has to be deployed, right? So that actually is not that bad. Right. Moving swiftly on. So that's how we are deploying a big data cluster. So now we have deployed it. How do we manage it? How do we manage it, right? So normally the way we manage a SQL Server installation is we are using a SQL Server Management Studio, and we are right-clicking in the Object Explorer, and we're getting nice little GUI stuff. Or if we are really adventurous, we are using scripts. But that's how we manage SQL Server. A BDC cluster. We actually has 2 things to manage here in a big data cluster. We need to manage the Kubernetes part, and we need to manage the big data cluster part. And for that, we have different tools. They are command line tools. So for the Kubernetes, you guys that have used Kubernetes before, You know about kubectl, or as the Americans call it, kubectl. I have no idea, but anyway, I say kubectl. We have, if you're on Azure, we have an Azure CLI command line called AZ, where you can create resource groups and stuff. And then finally, to actually manage the big data cluster, you're using a Python command line tool called AZData. Let's have a look. So let's go into the Windows terminal and run some stuff. So I want to see kubectl get pods SQL BDC cluster. So essentially, I want to. My big data cluster sits in a Kubernetes namespace called SQL BDC cluster. So now I'm saying, hey, let me see what pods do I have in this cluster. So we run that, and here we're seeing now certain pods, and there is one. Well, all of them are interesting to an extent. The dude here, master 0, right? That's interesting, right? Because that is where the SQL Server master instance lives, right? So let's see then if and to prove, well, to kind of prove that that is the case, let's, oops, sorry. To prove that that is kind of the case, I'm doing a new kubectl command where I'm saying, hey, give me the master 0 pod in the SQL BDC cluster and do some magic with an output. And what I'm saying is that I want to see what containers do I have here in this pod. So when I run that, we can now see that, yes, we have MS SQL. But we also have two other things here, collectd and fluentbit. And that's also open source stuff. And they are there to collect log information. And this is now talking to that control plane that I spoke about before, right? And that is partly what is feeding now into Grafana, Kibana, and all that cool stuff. Yeah. And then just to confirm that this is actually Linux and it is SQL Server. Let me see if I can find my mouse. I want to execute into this pod master 0, and I want to execute into the MS SQL Server container. I want to spin up the bash, the shell, and it's been deprecated. Okay, cool. Doesn't really matter, right? So now I'm in the root of master, and I can do a lot of bad things if I want to. So what I want to do is just show here that how we are seeding into var opt MS SQL, I think it is. And I think there should be a log directory there. Yes, there is. And we're hitting that. Right. And we're doing ls. And now, if you guys are used to SQL, you have probably seen these files before, i.e. log files from SQL Server. So yes, we are in Linux, but we are running SQL, and SQL looks more or less as it always has done. Cool. The final thing that I want to do is to exit out of here, and then, so I mentioned AZData before and how we are using that for the actual BDC cluster. I'm sorry, I'm looking at some live Q&A here, and Daniel Kelly the master of flat jokes asks, did Moses get annoyed by full tablet scans? Yep, he did. So he took his people and went away. Anyway, so AZ data. So now we have a lot of stuff in Kubernetes, inside Kubernetes. How do I interact with that? Right? So there need to be a way for me to get into Kubernetes, and that is exposed through endpoints. So I'm just going to show here AZ data, big data cluster, endpoint list. And now we can, what we are seeing here is various endpoints, and I don't want to really go into here and look at all of them, except for this thing. So the metrics dashboard. And I need to log into that. And yeah, I mean, if you're used to Grafana, you should you kind of know what this is all about. So here we now have dashboard for SQL Server metrics, and here I can choose what I want to look at. I want to look at master. And yeah, it's not very much happening there because I'm the only user. But yeah, so we do have the ability to also monitor, etc., from within without having to add anything extra to the big data cluster. Right. The final thing in here is that, so when we are going into SQL Server, into an instance, we normally access it through port 1433. In here, 1433 is kind of restricted for internal use. So the front end to the front gate to get into SQL Server is exposed through port 31433. That you can change that during setup, but yeah, so it defaults to 31433. Cool. Right, back to this. So that was a little bit about the architecture. That was a little bit about Kubernetes. Now then, how do we integrate and manage the data, which is, I mean, a huge part of SQL 2019 Big Data Cluster. If we look at data integration, we have essentially two ways of integrating data. We can do it as here on the left-hand side, data movement, where I have data in a source database. I want to be able to, from some other database, do queries, reports, what have you. So what we used to do in the old days, and well, what we are still doing, is we are moving data from here to here, and then we are querying the data sitting in here. The problem with this is that we are creating a copy of the data, and as some of us are painfully aware of, sometimes the copy is not 100% correct. We are missing data here, there, and everywhere, and it's a mission. The other thing is that your security department, well, I know ours at least, may not be that happy about copying large amount of data over the network, because that is now a new exposed way to be able to get to data in ways that you shouldn't be able to get to data. The other way to integrate data is to do data virtualization, where the data once again sits here in source. We have the database where we want to run reports on, But instead of moving the data to in here, we are creating, it's being virtually represented. It's being actually represented something by something called an external table. So me as a user wanting to run a report, do analysis, I am connecting to a table on this database here. I don't know better, but the actual query will be done against the source and the results comes back. And then finally, the results goes here to me. Obviously, well, in data virtualization, we are trying to push down the query to the source so that we are not grabbing a million rows coming up to this where it's virtually represented, and then we are assigning a filter. So we are pushing down and everything, including filters, down to the source. Okay, so that's data virtualization. So SQL Server and data virtualization then. If you look a little bit at the history behind it, and back in the day, we had linked servers, and I'm not aware of anyone that are really happy with linked servers. And when I first joined Derivco 10, 11 odd years ago, I was doing something where I might need a linked server, and I went to my boss, who now is the Rob Thompson, executive group head here, and a big shot, and complained to him and saying linked servers is so crap. And then Rob talking to the newbie, well, why don't you do something about it then? And I went off and I tried to create something that still actually is in use at Derivco. But anyway, so linked servers was one way. They were not ideal, but it was a way. Then we had way back something called, I think it's around SQL 2012 timeframe, maybe 2008, I'm not sure. We had something called analytics platform system, APS, where Polybase was introduced. And Polybase is essentially a way to where you through external tables that we will have a look at in a bit are accessing data, but it was kind of restricted. It was restricted to only Hadoop data. This shipped in your normal, let's call it that, SQL Server. It shipped with SQL Server 2016, so you guys may have seen and heard about it. After this, Azure SQL Data Warehouse introduced quite a few new features to Polybase, and then in SQL Server 2019. Regardless if it is the BDC or the normal SQL Server, we have a very enhanced Polybase. And as I've said a couple of times, Polybase works through external tables. So, and what is an external table then? Well, as the name implies, it is a table, but the data doesn't sit in the table. Right. The external table sits in whatever database in your master instance, and it represents either a remote table or a view, right? So it could, a remote table or a view. Important part here: no data is persisted in the external table, but you are accessing it without knowing, as I said before, that the data sits somewhere completely different. The data can, however, I can choose to cache the data for quicker retrieval, and we'll talk about that in a bit. Right? And as I said, queries is being pushed down to the remote source. Data Polybase versus linked servers. Just you can see here on the left-hand side what linked servers is doing, and the good thing about Polybase external tables on the right-hand side. One thing to be aware of with Polybase, and this is where it falls somewhat short, is that it's this part here. it supports read-only operations, whereas in linked server you can update underlying stuff. This will most likely be changed in the future or enhanced in the future. Right. So SQL Server 2019 then as a data integration hub. So we have our T-SQL, right? We have applications, analytics, whatever. We have created external tables, and initially, pre-2019, we could retrieve Hadoop data, but that Hadoop data had to be either in a Cloudera implementation or in a Hortonworks Hadoop implementation. In SQL 2016, we added the functionality to access Azure Blob Storage. So that's kind of what it looked like up until 2019. In 2019, we can now not only access Hadoop data and Azure Blob Storage, but we can access relational databases, such as Microsoft SQL Server, such as Teradata, and I don't know why anyone would like to do it, but also access Oracle. So we have poly-based support for SQL Server, Oracle, and Teradata. From a NoSQL perspective, we have support for MongoDB and Cosmos DB. And then the big thing here is that we have a generic ODBC support. So anything that has an ODBC driver can potentially be accessed through poly-based external tables. And that's a biggie. In addition here, we have in 2019, we now have scale out for compute performance through these compute pools that I spoke about. So let's have a look here. Let's have a look at this. So unfortunately, I have an Oracle database installed in Azure. And if you are Oracle peeps, you are probably aware of the Scott emp table. That's a little bit like Northwind in early versions of SQL Server. My connection has gone down, but essentially I have an Oracle database here. And you can see how quick Oracle is. Jesus. Where I have a table called emp, as I said, with some entries in it. Right. Now I'm interested in accessing this from my SQL instance. So I'm running here a notebook because I like notebooks. Let's see that, yep, we are in the right database. I have, in order to access something that needs credentials, you have to have a master key. And just because I don't want to give you what my passwords are, I have already created that. But essentially create master key encryption by password, and then we're creating a database scoped credential, which essentially defines now the user ID and the password, and I will use this against Oracle, if that makes sense. So let's just see that we actually have this, and here we go. Yes, we have an Oracle cred, etc., etc., etc. Then what I'm doing is I'm creating an external data source, and this is now defining where my remote source is. So I'm creating it the Oracle connection, the location, and the credentials. I created that, and now here comes the biggie, right? So now I'm creating an external table. I'm defining what it should look like, and I'm saying where it is and what data source it is. So this location here is now the table schema, well, actually the table schema, the service, the table schema, and the actual table. All right. Cool, so we're creating that, and that completed. So now what we can do here is select star from this table. And here we go. I now have queried an Oracle database sitting God knows where through SQL Server. So now your applications, your apps can now just execute here against that table through a store procedure or however you do it. Very, very powerful. And just to prove that that data is not persisted, let's run an exec space used against this table. And wow, here, right, index size 0, data 0, everything's a null. Cool. So that's an external table, and that's what we are using when we are doing now data virtualization. All right. Let's go on here. Right. So coming back to the architecture, the big scary picture here. Now what we're going to do is we want to look at three things here. We want to look at the compute pool, we want to look at the storage pool, and we want to look at the data pool. So the compute pool is essentially, well, it's a boundary, resource and a security boundary, and we are using it to process distributed queries. And something new in 2019, a big data cluster, is we have a distributed, well, query analyzer that can step in and look at a query and decide, should this query go straight against the resource, or should this query go to the compute pool so we can shard out the actual computation, right? So the compute pool then has SQL Server engine instances, and it's mostly there just for compute. However, if we need to do hardcore aggregation, expensive aggregations, we can offload data into local storage just while we are running this. So just an example here is that we have a user executes a query against SQL Server master, and then we are looking at SQL Server, the distributed query engine looks here at the query and defines that says, hey, we should probably use the compute pool for this because it is a good use case. And then this goes against relational databases, HDFS, or NoSQL in general. So that's the compute pool. Right, storage pool. Now we're getting into the interesting, the cool stuff here. So we saw in the diagram how, and we actually see here as well, how the storage pool, well, contains HDFS Hadoop file system instances. It also has a couple of SQL instances, plus it has Spark. And so this is now where we can store, well, Hadoop data, like Parquet data, CSV data, what have you. We also have the ability to mount other HDFS stores. So let's say that I have an HDFS, I have Hadoop somewhere else. I can actually mount it into the storage pool and retrieve data from there. Or if I have it some cloud like AWS or whatever. We can ingest data in here through Spark or SQL for that matter. And your normal access to this HDFS data is through SQL endpoints and TDS, but there is also a web interface, an HDFS endpoint, where we can use curl, for example, to send data to my Hadoop file system. And this essentially now gives us the ability to create a data lake, or multiple data lakes for that matter. So let's look at that. Right. So let's see if we're, so here we're going, so what we are doing now, so remember in Oracle, what I did was I created a data source. Actually, before we go into the meat here, let's have a look here at the left-hand side. If you look at the left-hand side here, you can see that in Azure Data Studio, we actually have an HDFS directory. And here we can create our own directories and then upload data to these directories. So let's have a look. Here. Clickstream data, right? So here I have a CSV file called web clickstream CSV. Cool. I can do a preview what it looks like, and this will take a little while to spin up. And here we're now seeing some random data in my clickstream CSV file. And what I want to do with this is that I want to create an, stop that, new, I don't want to do that. What I want to do here is that I want to create an external table against this clickstream data, so I can do queries against it. So what we're doing here is we want to create an external data source called SQL Storage Pool, and that has a specific address, SQL HDFS controller. So that's essentially the pod that we're sitting in, and that will now give us access from SQL into the storage pool. So we're running that. That's cool. When we are doing non-relational data, we also need to define the file format. So what is this like? Is it a Parquet file? Is it a JSON file? Well, what is it, right? So here I'm creating now, seeing that my clickstream data was CSV. I am creating an external file format called CSV file. I mean, the name doesn't really matter, but that's what I chose to call it. And I'm saying that it's the limited text, what is the field terminator, what's the string delimiter, and etc., etc., etc. We run that, we have completed it. Let's just check that we're in the right database. That's happened a couple of times that I've been in the wrong database. And here we now have Niels database CSV file. Awesome. Now what I can do is create a external table. So we're creating an external table that I call web clickstreams HDFS CSV. That was quite a mouthful. And what columns and data types, what is the data source, where is the location, and what is the file format. And the location is then starting from the root of the HDFS directory over here on the left-hand side. We run that, and we have created now this external table. And then finally, if the demo gods are with us, let's do a select against it. And now here we have now the result, right? We have some data coming back, the top 10 rows. And once again, if I were to run space used, well, it would be 0 because we are not persisting data in this table. But we can now run queries, we can do filtering, cool stuff like that. Right. So that's the storage pool. Let's go back to the slides a second. And remember what I said, that these external tables are not persisting data, but we could persist data if we wanted to. And that's what we're doing through this thing called the data pool. And the data pool is there as a cache. You don't really want to have all your data in the data pool. But for example, if you're a data scientist and you're running experiments, and instead of executing a remote query against somewhere, and then you want to rerun, you may want to cache the data so that is easily retrievable and you get a better performance to get the data. And that's why you're using a data pool. So, and this is now essentially sharded database instances. And we can ingest data either through SQL or we can ingest data through Spark. And as I said, it's a sharded, these are sharded based upon an algorithm that either you can provide or choose an existing algorithm. And as I said, I'm lazy. I'm always using a round robin algorithm. So it will be evenly spread out across the various shards here. So let's have a look at that. Right. So data pool. Cool. Niels database. So here's an example. So right now I'm using, remember that external table I created against the clickstream stuff. Here I want to do some stuff. I'm doing some aggregations based upon category IDs and things, right? And I'm selecting 100 selecting top 100 here. When I run this will take a while. So it will take around, well, probably 30 seconds. So what and that obviously is too long. We want better performance. So what we are saying here now, okay, let's cache this data into the data pool. Right? And while I let this run, I'll just, so here we go. So it took 26 seconds to run that, and that is too much. Right? Okay, so what we are doing the same thing as we did with the storage pool. We are creating an external data source, and we're just giving it a name. It could be anything, right? But I tend to go with the SQL storage pool and SQL data pool, but you could call it whatever you want. So we run that. And we have an endpoint for that. So this is the entry into the data pool. We are creating an external table, which will keep this aggregated data. Oh, come on. Right. And then we now ingest data here into the data pool. And this, once again, this can be done with SQL, as you see here, or we could do it with Spark. And once again, this will take a little bit. So it's around 500,000 records, if I remember correctly. And then what we do, so that query that we run up here, by the way, right, that is joining from the web clickstream data against a table, a normal table in another database. So cool, that's that. 585,306 rows affected. Let's just make sure that we have data there, so I'm not lying too much. And yes, we have some data. Cool, awesome. And now let's run against this. Let's do the same query, but now against the external table. And this will take around 6-7 seconds, actually 5 seconds. Cool. So exactly the same query, but now by having this data cached in the data pool, we get it. I mean, we're getting back a lot faster. All right, so let's see then what has happened here. So something new, exec at. So what I'm saying is I want to execute select star from sys databases in the SQL data pool. Look at this. So when we are creating a data pool, that database will be created in the actual data pool. And we are now sharded across 2 instances. So I will have 2 copies of that database. But until I populate some data into an external table, there won't be any data in these databases, if that makes sense. All right, so let's do a select star from sys tables. And here we can now see that I have 2 tables, web clickstream data, data pool. And finally, for the data pool, let's look at space used here. So I'm saying execute space used against this table. And we now see that we have here 292,000 rows and here 293,000 rows. So the data has been sharded out across the various instances. Cool. So that's data virtualization. That is how we are creating data pools, how we're creating storage pools. I mentioned Spark. And we'll talk a little bit to Spark in a little bit. I'm checking time. We're doing quite good, I think. We can also use Spark to ingest data. So Spark is an open source thing. You can do. It's a stream. Well, it's both batch and stream, where it's a it's a distributed streaming and batch thing where we can parallelize huge workloads over Apache Spark, and Apache Spark we can access data, different types of data. We can access data in SQL Server, well, in relational databases. We can access data in Hadoop file system, and as I said, we can do it in batch, or we can do it in a streaming fashion. And it supports different languages, right? So you can write Spark stuff in Python. You can write Spark stuff in Scala. Microsoft has now a Spark. We can write Spark stuff in C# as well. So it supports a lot of languages. So what we want to do here is that I have here on the left-hand side again, I have something that I call Spark data over here, and in there, I should have done this. I have a CSV file, adult census income CSV, that has information about census information about adults, as the name implies. So I want to do some stuff, and in Spark we're talking about data frames, right? So we are reading things into data frames. So I'm doing some setup stuff. I'm saying, where do I find my file I'm interested in? And then I'm saying Spark read is CSV format. Do I want headers? Should I infer schema? What about white space? What about leading white space and about trailing white space? And then I'm doing some very rudimentary data engineering, actually not data engineering, but I'm replacing a hyphen with an underscore for column names. Right. So let's run that. And here we go. And here I'm now actually using, if you're looking up, actually, let me show you something. Look up at the top, i.e. the kernel I'm using here in a notebook. So right now I'm running PySpark, but I could have written it in Scala. I could have written it in other languages. So here I get now, I've read in the data file. I haven't really done any Spark thing yet. I have done very rudimentary stuff. Now what we want to do is we want to write to an SQL table, right? And we are using an SQL Server connector for Spark. We are setting up some connection information, what database name to use, user and password. And you don't see this. I will change that after this webinar. And then we are essentially writing here to we're calling data frame write, and we are now ingesting data into a table. This table is now doesn't exist, so we are creating it. It could have existed, or we can create it. And right now we are creating it. So we run that. Oops. Ha ha ha. Ha ha ha. Yeah. So I haven't really actually. Yeah. So I got an error here. Sorry, I got an error here saying that I cannot open the database requested by the login, and that is because I haven't created the login in that database. Fear not. Let's change over to a database where I have created it, Niels Database 3, and let's. So after a webinar like this, I'm ending up with Niels Database 99, adult census test 43, etc., just to when I'm showing stuff. But yeah, so let's run this. We are starting. So Spark, it takes a little while to heat it up, but this went fairly quick. And we are now using, we have used the MS SQL connector to write to the master instance, and it said it succeeded. So let's see. And yes, lo and behold, we have now here a new table called adult census test 3. And we have some columns in here. Awesome. We can read as well from here if we want to. So let's run that just for fun. And we're saying show 5 rows from this table. And here we are, right? So now what we have done, we have seen how we can use Spark to both read and write data, relational data, or we actually read Hadoop data and we ingested it into a SQL table, and then we have read SQL data and we could ingest it to somewhere else. And the thing here is that with Spark, you don't need to manually execute things like this. You can use jobs to execute. You can have a running Spark job that runs continuously, etc., etc. And this is, so imagine now that we want to move data from, let's say, from a relational OLTP database into an data lake for long-term storage. We could use Spark to do that. We could have a Spark job that reads from the relational database and ingests it, the difficult word, into Hadoop. I mean, what we can do here is endless. We can do a lot of really cool stuff. Right. We can also write it into data pools if we so want. I'm not going to run that because there are some issues on my environment right now. But yeah, we can essentially write to wherever we want to write. Cool. So that was Spark ingestion. So now then, analyze data, and we're coming up towards the end. I will probably go over a little bit, but not too much. So as we said here, so now we have the ability to analyze all sorts of data, because we can run Spark jobs both over structured data as well as unstructured data. We can access data in SQL Server, and we can query down against other data sources such as Oracle, MongoDB, what have you. And we are then letting the actual Spark job return data to the notebook, or maybe ingest it into some SQL table. So back in the old days, the way we got data was to use SSIS, right? And we ingested it into a master instance, and then we may use SQL Server machine learning services. So SQL Server machine learning services was introduced back in SQL 2016, I think it was, where we can run R and Python in SQL Server, and that we can still do that. We can run machine learning services in SQL Server against data in SQL Server. But now we have the ability, the added ability, to use Spark and run Spark machine learning for really, really big workloads. Yeah. And we can create a model, we can serve the model, and we can then evaluate against the model. Remember what I said about Microsoft and open source and Linux, how things have changed, right? In SQL 2019, Microsoft introduced something called the Java language extension. And that is the ability to execute compiled Java code from inside SQL Server, but outside the server process. So SQL CLR, remember, there we can execute CLR code inside of the SQL process. With the Java language extension, and R and Python for that matter, we can actually execute Java stuff from inside SQL Server through normal T-SQL, through specific, by using something called an SP, a proc called SP execute external script. If you're interested in Java, on my blog I have quite a lot of information about running Java code in SQL Server. But I'm coming back to here how things have changed. So back in the end of 1990s, 1999, maybe 2000, Sun came out with Java, Sun Microsystems, and Microsoft at that time tried to promote the upcoming .NET, and they also were in competition with Sun. So Sun had the Java language. Microsoft came up with a competing Java language called Jakarta, because Jakarta is the capital of Java. So kind of, yeah, there were some nastiness going on there. We know that Java and Microsoft never really happened, but now 20 years later, we can now execute Java from Microsoft's flagship product, SQL Server. It's amazing. It's amazing. But anyway, so here, the idea here is that there are certain things, especially in machine learning, where you can't run R and Python, or from a performance perspective, it is not good enough, but Java has good support for it. So the idea is that you can create a Java class that is doing something particular with machine learning, what have you, and execute against that Java class and get results coming back. So that's the Java language extension. And then obviously, once again, we have Spark, right? So to finish this off, what I want to do is, so we have this adult census thingamajiggy file. I want to read it in. I want to do some feature engineering or get some information about the data. And then I want to get labels and stuff. Want to split this training and test, and then train a model and run a model. So we'll just run through this just to show that we can actually use Apache Spark in big data cluster for machine learning purposes. So get my data file. Hello. Invalid status code. Why is that invalid status code? And this is fine. Okay, so something has gone wrong, so we're not going to show it. But eventually, so essentially, is that if I were to run this, I would essentially get results coming out like this in the notebook. And that's why it's cool to have a notebook, because the notebook interleaves, well, your code with results. So you can take the notebook and you can send it off to someone and say, hey, why is this not working for? Hey, look at how this is working out really, really great, etc., etc. Right? So essentially, I'm doing some feature engineering. I'm split some here between training and test. I'm training the model. I'm getting a score where I'm essentially area under the curve and etc. This is not a really good model, but at least it is a model. And I can now persist this model into Spark and then reload it and run real data against it. All right. So we are virtualizing data. We are ingesting data into either relational tables or to Hadoop. And then we have a complete AI platform with SQL Server machine learning services and Spark and Spark ML. And summary, data volumes increases by the second. Well, you can read what I'm here. So we need a way to handle the data, and SQL Server 2019 Big Data Cluster is a way to do that. Runs on Kubernetes. In this the SQL Big Data Cluster, we have a control plane, we have a master instance, compute pool, data pool, storage pool, app pool. We can use Spark, and in SQL 2019 in generally, Polybase works against more storage types than pure Hadoop and Azure Blob Store. And that's that from me. Right, so let's see here. We have some questions. So I'll try to take some questions now. Okay, so Chris asks, depending on my data size, how do I spec my server regarding hardware specs? There are quite a lot of documentation on Microsoft's on the web regarding how to spec your machines, etc. Then Carl thinks that I have such an awesome sense of humor regarding Oracle. Yeah. Right, my HIN are so many moving parts to this system. And it's, in essence, what my HIN is saying is that there are so many places where this can go wrong. Can we scale storage pool dynamically? Can we scale up and down easily? Yes, we can scale dynamically, absolutely. Easily, can probably be a little bit better. So Andres K. a blast from the past. Could I create an external table against an S3 bucket in AWS, thereby incorporating and pulling in data from AWS? Absolutely. Yes, you can. With Andres K again. With SP execute external script, you could generate events with an with any incoming bits and send these via Java to an event collector, thus replacing CLR procs. So Andres is talking about some guy whose name should not be mentioned, created SQL CLR procs, and we took out data from, that guy took out data from the casino database and sent it out to external systems. So Andrew's question is, can I do the same with external, execute external script in Java? Yes, absolutely. I actually have a blog post, I believe, about how using this and send, using Java and send data to Kafka. There are some other published here. John thinks that I'm such a hipster. Yeah, well, that's not what I would call myself, but anyway. Anonymous says, so basically, if I have a Kubernetes cluster on AWS, I can install a BDC on AWS. Absolutely, right? So you could run an Redshift open, so Red Hat OpenShift platform or kubeadmin or whatever. Absolutely. And we already know that Moses got annoyed by full tablet scans because he went away. Right, Gandhi, and I think that then I have answered all the rest of the questions. With that, once again, thank you guys. It's been a pleasure. And if you have questions, etc., send them to my HIN. Email me, ping me, and I'll answer the best I can. Cheers and thanks, guys.
Cool. Thank you, Niels, so much. Niels's email, we'll just drop it into the chat any moment. We'll now hand over to Rob Thompson, Executive Group Head of Player Experience, to say a few words.
Hi, everyone. Firstly, I want to thank Niels for such an engaging and valuable session. I could certainly go for another lap or two with him, keeping us up to date and informed about the latest platforms out there. Niels, your linked server story reminds me of how much can be achieved when we leverage new technologies effectively. In this session, we've seen how SQL Server 2019 Big Data Cluster is built for handling lots and lots of data in different types and formats. At Derivco, as many of you know, we have lots of data, and we can see how SQL Server 2019 Big Data Cluster can help us. Some potential use cases are using the data virtualization capabilities to be able to query data from different sources in a transparent way. Also, the ability to move data from the relational OLTP source to the data pool and also to HDFS gives us the ability to age out old data, but still be able to query it as if it was still hot. And that's very interesting. And finally, the ability to use SQL Server machine learning services and Apache Spark for analytics is huge, and using it can be highly beneficial. It goes without saying that as an industry pioneer and a company that prides itself on being at the forefront of tech, we feel it's important to keep on trend with the latest platforms. And sessions like these will keep us there. We hope you enjoyed it and look out for more in the months to come. Thanks.
Thanks, Rob, and thanks to all of you for tuning into our second Derivco Tech Thursday webinar. If you'd like to join us for future events, and especially if you're from outside Derivco, keep an eye on our socials. We actually share invites as well as our links to register on all of the major platforms. Also look out for a short questionnaire that will be sent out tomorrow. We want you guys to share what you liked, what you didn't, even suggestions on future topics. We actually looked at our last survey and that actually inspired this topic. So we are listening to you guys. And one last thing, if you want to rewatch the session, we will be uploading it to our YouTube page by tomorrow. I'll leave it at there. Take care and I'll catch you at the next one. Cheers.
Bye, guys.